Okay, let's see how we can solve this problem. Triangle ABC and triangle BCD are right angle triangles. Find the length of line DC. Okay, so we are looking for the length of line DC, and this DC is labeled X here. Okay, now for us to find this X, we have to draw out these triangles out from this diagram, because in this diagram we have two triangles, which is BCD and B and ABC. Okay, so that is what I have done here. So this is a triangle BCD and triangle ABC. Okay, now in this very triangle, our line BC is the hypotenuse of this other triangle. Okay, now, and we are looking for DC. Now, since we don't have any other side here that we can use to find this line DC, we have to come over this side and find line BC, so that when we find line BC, the value we have here, we can now add it to this place. So the value here will now become the hypotenuse of this very triangle. Okay, so let me label this line BC Y. Okay, now since I have two sides in this triangle, and it is a right angle triangle from what we have, it is a right angle triangle. Look at it here. Line ABC is a right angle triangle, and it is indicated in this our question. It is a right angle triangle. So because of that, I can use Pythagoras theorem to find the value of y. So this is hypotenuse, and this is our x will now be here, and this is our y. So remember that the formula for finding any side using Pythagoras theorem is hypotenuse square is equal to x square plus y square. Now, since we are looking for y, it will now become y square is equal to hypotenuse square minus x square. Okay, so we just have to substitute these values here. So we now have that y square is equal to, instead of writing h, our h is now 19. So 19 square minus 13 square. Okay, so let's find the value of 19 square. So 19 square is equal to 361, then minus 13 square is equal to 169. This is y square. Okay, so let's find the differences. 361 minus 169 will give us 192. So y square is equal to 192. Now, since we are looking for y alone, not y square, we have to find the square of both sides, square root of both sides. So we find the square root of both sides. Okay, so that square root of y square will become y, and square root of 192 will be 13.86 approximately to 2 decimal place. Okay, now we have found our BC, and this is also the same as this place. So this place is now 13.86. Now for us to find the value of DC, since one side is given and an angle is given, we can now use SOHCAHTOA. Okay, so SOHCAHTOA is normally used to find a side when another side is given and a particular angle. Okay, Now, because this is our hypotenuse is our 13.86, and the line DC is now our adjacent. Of course, we have an angle. We will now look for the acronym that will contain hypotenuse, angle, and adjacent, and that will be CAR. That will be CAR. Okay, which means cos theta is equal to adjacent all over hypotenuse. Okay, now our cos theta is cos 23, which is equal to, our adjacent is DC. We are looking for DC. Line DC is our adjacent, and our hypotenuse is now 13.86. Okay, so we will now cross multiply to make DC the subject of the equation. So if we do that, it will give us line DC is equal to cos 23 times 13.86. Okay, so cos 23 is equal to 0.9205, then times 13.86. Okay, this is our line DC. Okay, so if you now multiply 0.9205 times 13.86, we now have 12.76 cm. Okay, to 2 decimal places. Okay, so this is the value of line DC. Okay, we have another example here. In the diagram above, angle ADB is 90 degrees. So that is the sign here. Line AB is 15 cm. Line AB is 15 cm, and line DC is 10 cm. Line DC is 10 cm, and angle BAD is equal to 60 degrees. Angle BAD is 60 degrees. Okay, that is what we have here. The whole of this angle is 60 degrees. Okay, now find line AD, and this line AD is labeled X, and line BC, correct to 2 decimal places. C, angle DAC, correct to the nearest degree, angle DAC. So this angle DAC is now alpha. Okay, now for us to find these sides and the angle we are looking for, we have to cut out the angles, the triangles that we have in this diagram. Okay, we have the first triangle, the biggest one, which is ABD, and that is what I have here. And we also have ACD, that is what we have here, ACD. We also have ABC, but I don't really need ABC, so I will not draw it out. Okay, now the first one, which is line AB, so I'm looking for line AD, which is this place, and is labeled X, and this angle BAD is 60 degrees. Okay, and this place is 15 cm. Now, since we have an angle, a side, and we are looking for another side, we can use SOHCAHTOA, okay? And in that SOHCAHTOA, we are going to look for the acronym that contain hypotenuse, adjacent, and an angle. And that the acronym is CAR, okay, which means cos theta is equal to adjacent all over hypotenuse, okay? So now our theta is 60 degree, so we now have cos 60 degree here is equal to our adjacent is x that we are looking for divided by hypotenuse is 15, okay? So we now make x the subject of the equation. So x times 1 will give us x is equal to cos 60 times 15. Okay, so let's look for the value of cos 60. So cos 60 is 0.5. So we have 0.5 here, then times 7 times 15. So 0.5 times 15 is 7.5, 7.5, okay? So 7.50 to 2 decimal places, 7.50 cm to 2 decimal places, okay? That is the value of line AD, okay? So line AD is what we have here. Now, the next thing is line BC, okay? Line BC. Line BC is this place. Now, for us to find line BC, we need to find the value of line BD. After that, we now take 10 cm away from the value we got, then the remaining will now become the value of line BC. So that means that line BC is now equal to line BD minus 10, okay? So that means we now need to find the value of line BD, okay? Now, this is line BD. Now remember that we have gotten the value of x, which is AD, and that value is 7.5. So we can either use SOHCAHTOA to find BD, or we can use Pythagoras theorem, okay? Now, Pythagoras theorem states that the square of hypotenuse is equal to the sum of the squares of the other sides of the right angle triangle, okay? Now, we can take, this is our x is 7.5, and hypotenuse is 15, so we can now label this place as y, which is BD. Now, for us to find y, we have to make y the subject of the equation, which will now give us h square minus x square. Now, our h, which is hypotenuse, is now 15 square minus x, which is now 7.5 all square, okay, is our y square, okay? So we now find 15 square is 225 minus 7.5 square is 56.25. Okay, let's find the difference. 225 minus 56.25, it will be 168.75. That is our y square. Now for us to find the value of y, we have to find the square root of both sides. We have to find the square root of both sides, and the square root of y is y. Square root of y square is y, and square root of 168.75. So we say square root of the answer is 12.99. 12.99. Okay, that is the value of line BD. Okay, so line BD is now 12.99. But remember that we are looking for line BC, so that line BC now will now become 12.99 minus 10. Okay, so if you take 10 away from this, it will give you 2.99. That means that our line BC is 2.99 cm. Okay, now let's look at the last one. So we have we are to find the value of DAC. Okay, angle DAC, angle DAC. So the angle is alpha. The angle is alpha. Okay, and DC is 10 cm. Now, before now, we have gotten the value of line AD, and our line AD is 7.5 cm. Okay, so we can now use SOHCAHTOA to find the value of alpha. Okay, now this is the opposite and this is the adjacent. This is the opposite. Okay, now we are going to look for the acronym that contains opposite, adjacent, and angle, and it's going to be TOA, which is tan theta is equal to opposite all over adjacent. Okay, now here our theta is labeled here alpha, so we now say tan alpha is equal to our opposite is 10 all over our adjacent is AD, which is 7.5. Okay, so 10 divided by 7.5 is equal to 1.3333. So tan alpha is this. Then alpha alone will now be tan inverse of 1.3333. Okay, so that means second function tan 1.3333 is 53. Okay, so alpha is 53 to the nearest degree. Okay, that means that the angle we are looking for, angle DAC, angle DAC is equal to 53 degree, okay, to the nearest whole number, okay.